All right, so we're now going to start on the second problem on your homework assignment. This is problem number 3 in chapter 1 of the textbook. All right, so let's compare the surface to volume ratios of a typical E. coli cell using the dimensions given in problem 1 and a spherical eukaryotic cell that is 20 micrometers in diameter. All right, how does this difference affect the lifestyle of these two cell types? All right, so that part I'm going to leave up to you. What you need to be looking for, all right, are the E. coli cell. It gave you dimensions of well, it said it was a cylinder with a diameter of 1 micrometer and a height of 2 micrometers. So look up the formula for the volume of the cylinder. Right, for the eukaryotic cell, it's saying that we're dealing with a sphere with a diameter of 20 micrometers. So look up the equations for both the volume of both, of a sphere and a cylinder, as well as the surface area of a sphere and a cylinder. Right. So that part should be relatively easy for you. All right, the second part of the question, though, is where the problem comes in. All right, it says, in order to improve their ability to absorb nutrients, the brush border cells of the intestinal epithelium have velvet-like patches of microvilli facing into the intestine. All right, how does the surface to volume ratio of the eukaryotic cell change if 20% of its surface area is covered with cylindrical microvilli? They're 0.1 micrometers in diameter, 1 micrometer in length, and occur on a square grid with 0.2 micrometer center to center spacing. All right, so I realize that this is that's a ton of information there. All right, so there's a lot of numbers. It's very helpful in this problem to draw pictures and to get all the numbers right in front of you. So first things first. All right, I'm going to assume you did the first part of the problem. All right, I'm going to give you a number that's just made up. I think it's close to the right number if I recall correctly, but I'm not going to give you the answer to the first part of the question. All right, but we're going to assume that the surface area of our eukaryotic cell, we're going to say that it's 1,000 micrometers cubed. I'm just going to make the math a little bit easier here. All right, so if we read this part of the problem, all right, it says it's after, how does the surface to volume ratio change? So we're going to need to determine the surface area of this patch with these microvilli. That's the first thing we're going to need to do. All right. The second thing we're going to need to do, all right, it says, all right, the next thing it says is that 20% of the surface area is covered with these microvilli. All right. So you guys already calculated the surface area of this eukaryotic cell. All right, so we need to know, the surface area of this patch. Right, is 20% of this. So, hopefully you guys can do the calculation and figure out that in this case, all right, this patch is going to have a surface area of 200 micrometers. All right, so there's step one. So we know the surface area of the patch that we're dealing with. All right, let's read a little bit more carefully. All right. It says it's covered in these cylindrical microvilli. All right, we'll come back to that. And that they occur on a square grid. All right, so we basically now have a square grid that has a total area of 200 micrometers. Oh, sorry. Oops, my bad. Area has units of length squared, not length cubed. Oops. All right, so it should be 1,000 micrometers squared and 200 micrometers squared, all right, respectively. All right, so if we have a square here that has a total area of 200 micrometers squared, right, each side then, right, the area of a square is, the length of each side are, squared basically. Our squared is going to be the area. All right, so if we have the area and we want to figure out r, or the length of the sides, all right, all we're going to do is take the square root of the area. All right, so that means each side here has a length of the square root of 200 micrometers. Right. Obviously, your numbers are going to be different than this, because I'm just throwing out a number here for surface area. All right. So now, all right, now we're ready to start filling in this patch with microvilli. All right, so the problem gives us the dimensions of our microvilli. So it's saying that they're cylinders. Right. And it's also talking about the proximity of one cylinder to another. Right. So the information it gives us, it says that these microvilli are cylinders that are 0.1 micrometers in diameter. So we know that this number right here is 0.1 micrometers, right? And they have a height of 1 micrometer. And the other piece of information it gives us is the center-to-center spacing of these microvilli, right? So it's saying that from the center here to this center, right, this distance here is 0.2 micrometers. Right, so we know that the diameter here is 0.1 micrometers. It means that this little portion here, right, is 0.05 micrometers. And so is this part here is also 0.05 micrometers, which then means, right, you can figure out this part, right? What is that distance, right? We can figure out all the, basically now the spacing of our microvilli. Right? And using all this information then, we can figure out what the total length is from one side of the microvilli to the other side of one here. All right, so now we want to start basically putting microvilli into our square grid here. Right? So we know, the amount of length to go from one side of one to the other. Right? And we also know the length required to add on an extra one and an extra one. All right, so it's up to you now to figure out how many of these microvilli can fit into this square root of 200 micrometer side, right? And then likewise, it'll end up being the same number of microvilli going down, right? So then you can basically square that number, and now we have the total number of microvilli that are going to be on this patch. All right, so the question though is asking us, so we now know how many microvilli we have. All right. The question is asking us how much added surface area do we actually have. All right, so if we're looking down at this patch here, right, we want to think about which portions of these cylinders are actually adding to the surface area. All right, so looking down here, right, think about it. All right, is the top of the microvilli, top of the cylinder, is that actually adding to the surface area here? All right, now what about the sides of the cylinder? All right, so I'll leave that up to you. Figure out which parts or part are adding to the surface area here. All right, and then figure out for a single microvilli how much surface area a single microvilli adds, and multiply that number by the total number of microvilli. Then you have your added surface area. And from there, it should be relatively easy to figure out basically the added surface area to these cells.